Let's actually talk about these two recent papers that we got accepted at a conference called the Conference on Robo-Learning. This conference is a really top conference on bringing machine learning to robots to understand how machine learning can help robotic systems to advance. And these two papers, actually, I'm really proud in a sense. We are a new group. Everyone is new. I started last year. Everyone else started last year. We actually work fully remotely without seeing each other physically for a year. But almost every student I started with me have their first one or two papers already published from the Realm group. One paper is about robust certificates for autonomous systems. It's actually aligned very well with what I described. This paper it's about discussing robustness that we can more robustness we can achieve by building neural certificates, the neural proofs that we can jointly have for when we design autonomous systems. So, for example, in this one, we look at a couple of examples. One of them is a satellite docking problem where we have a chaser satellite, we have a target satellite. Now the chaser is trying to dock to the target within given amount of time. There are a lot of uncertainties in space, and the target could suddenly move. So the problem itself is a really complicated sort of space mission in a sense. The docking has to happen within really short amount of time, otherwise the satellite will run out of battery. And when the chaser is approaching the target, it has to approach it through a very unique angle. Otherwise, that's where the system is designed so they can dock. Otherwise, they will just bump to each other and fly away. And given all those uncertainties, it's really difficult to design a policy that can make sure this docking can always happen successfully. And an unsuccessful rendezvous of the satellites is going to be a really costly process. Now, what we did was we want to build a neural certificate, and this certificate is robust to all the uncertainties that we can all the uncertainties that can happen. And we have this proof showing that it's always safe. So the chaser will always be able to dock through that right angle, using that right angle, and it will always finish the docking process within a given amount of time. Even if there are uncertainties, if you use traditional methods, sometimes there are a lot of uncertainty, then the chaser will just fly away instead of approach to the target. But for us, we always have the strong guarantee that this docking will always happen. Even if you have a large range of, for example, the inertia or mean motion of the different components of the satellite. Yeah, so this is I started to think about this problem with my student maybe a year ago, and we've been through a lot of iterations and finally reached this idea. So this whole idea of building a neural certificate, neural proof together with a policy is a really, really new domain. The first paper only appeared in 2020. So we pick up there, we quickly catch up on, I would say we are the leading lab here worldwide that work in this area and can always certify your machine learning algorithms.